Assalamualaikum and very good day. My name is Muhammad Azri as a leader of Group 9 for IDP 1. Our mentor is a Dr. Ahmad Syayuti Abdul Rahman and our title is a Smart Irrigation System. Today I will present about Chapter 1, which is Introduction. According to the statistic, agriculture uses 85% of available freshwater resource worldwide. This percentage will continue to dominate in water consumption due to the increase in the food demand. Traditional and conventional farming are still widely practiced, especially for farmers that live in rural areas. But the problem statement with the traditional farming, it will waste more water because water is irrigated to the land directly. Next is require a large human resource because water reservoirs are far away. It will waste energy and time. So the third is most farming system that available on market is very expensive in terms of the budget. So we are here to design smart irrigation system. Smart irrigation system is a system to help farmers controlling their crop condition automatically based on sensor. The objective is the system should be sustainable, affordable, while maintaining the crop conveniently. We are use Industrial Revolution 4.0, which is Internet of Things, in order to support SDG goal number 12, which is responsible consumption and production. That's all from me. Thank you.
Assalamualaikum and a very good day. My name is Nur Syafiqah binti Cik Rashid and I will represent to you about chapter 2, which is need analysis. First is 2.1 market survey. This section focuses on outlining current available products of existing precision farming system. This is to understand the key performance of the product toward obtaining customer requirements and also to determine the best feature among the three selected which performance best suit customer requirements. This is the three selected product. The first product is Gardena Micro Drip Irrigation System. Gardena Micro Drip Irrigation System is a timer-based irrigation system that is powered by a battery in order to supply water to the plant. The second product is manual simple irrigation system, which is a simple manual watering system that requires electricity from the power grid. The third product is TP Hive XR Smart Sprinkler Control, which is a Wi-Fi based sprinkler timer used to irrigate farms. The next is 2.2 Design of Market Survey. In this survey, it is targeted to obtain about 50 respondents through questionnaire. Questionnaire is a set of questions created to gather information. In order to carry out the survey efficiently, especially through this pandemic situation, the questionnaire is generated through Google Form, where it gives advantage in terms of reaching farmers, especially those that stay in rural areas. This questionnaire consists of three separated sections, which are Section A, Section B, and Section C. The next is 2.3 Survey Analysis. Section A is Demographic Profile, which is also known as personal information. It consists of gender, age, and also scale of farms. The next is Section B, which is General Overview. Here is the question that we ask the respondent to answer. In this section, it helps to understand what are the problems related to the farms. And the last is Section C, which is Customer Requirement. This section is about respondents' opinion on the solution provided through Likert scale types of questions. This information corresponds to the customer requirement which will be implemented on a house of quality. Here is two charts that consist of 10 solutions that have been answered by the respondents. From the results obtained, it shows that the smart irrigation system should be environmental friendly is the highest requirement. and shows that it is the main priority for the system, followed by the other criteria. That's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Nondalila Arina binti Muhammad Fauzi. I will explain about chapter 3, which is design specification. We go to HOQ first. Cost of quality is defined as a product planning matrix that is built to show how customer requirements relate directly to the ways and methods companies can use to achieve those requirements. Cost of quality diagrams use a design that resembles the outline of a house and can be created using technical and competitive benchmarking data. HOQ also considered as the primary tools that used during quality function deployment to help facilitate group decision making. Benefits that we can get from house of quality is the customer need and requirements are established, then used to build and prioritize use service offering and products. Second, we can identify customer needs and requirements, then ensuring that they are achieved leads to customer satisfaction and loyalty. This is HOQ chart. As we can see, on the left side is customer requirements. On the upper side is design requirement, which is we call it as engineering characteristics. So there are 10 customer requirements that we get from the data collection. First one is reliable, easy to maintain, minimize water usage, save time, smart water control system, low electricity usage, affordable, environmental friendly, easy to use, and reduce manpower. We need to rate the importance based on customer requirements. We can see that the customer importance consists of 5 and 4, which is 5 is the highest. So we can conclude that there are certain customer requirements that importance to the customer. Then we look at engineering characteristics. We conclude that from our design, it consists of cost, material rigidity, volume of tanks, weight, durability, time taken to install, electricity, and expected lifetime. Next, we see customer competitive, which is Gardenia micro drip, manual system with mixer, and smart sprinkler control. From this rating, we can see that Gardenia micro drip has the highest rating. Next, we move to product design specification. What is product design specification, or PDS? Product design specification is a listing of the critical parameters, specification, and requirements for the product you are designing. It is a statement of what the product should be and should do. PDS is created during the problem definition activity very early in the design process. Why product design specification is important? PDS is important because they can provide clear instruction on project intent, performance, and constructions. So these are the product design specification of our project, which is smart irrigation system. First, we have product identification. As we can see, it is affordable precision farming system, away from electrical grid and power system. Smart watering system that avoids plant from drying out. Next, market identification. It consists of small agricultural and small holdings, and farmers have limited space for farming. The third is special feature Arduino microcontroller in our project. Arduino microcontroller used to operate solar power pumping system. Then, we also use moisture sensor. The moisture sensor is to detect moisture in the soil. Fourth is financial requirements. Pricing policy over the life cycle is the target manufacturing cost is later to be discussed, and also estimate retail price is also to be discussed. Then we have key performance target. We can collect and distribute the available source such as water source and utilize resource in a smart way. We can water the crops in both wet and dry season. After that, we have life cycle targets. It is useful 5 years of life and beyond. It also has maintenance schedules. Next, we have service environment. It provides long-term warranty and low maintenance costs for the product. Renewable power is also available every day, and even on cloudy days we produce some power. Then we have key project deadlines. It takes 6 months to finalize a design. Our target is for the dry season and rural area. Next, we have social, political, and legal requirements. We will follow the safety and environmental regulation. All the safety precautions will be followed in the installation process to avoid any injuries. Then we have physical description. We have solar panel dimension consists of 1 meter long and 1 meter wide. Then we have Arduino system and pumping system. For manufacturing specification, all framing and components will be installed and manufactured by the user. That's all from me. Thank you.
I am Ko Ying. I will continue with Chapter 4, Concept Generation. In the generation phase, we use several methods to analyze concept. First, functional decomposition. Physical decomposition of smart irrigation system. We divided three main subsystems, which are mechanical subsystem, control subsystem, and power supply subsystem. Functional basic, standard flow classes and member flow type. The table shows the flow classes of energy, materials, and the signal transmission. Systematic design. For function structure, energy will flow in the system. This energy is solar energy, mechanical energy, and human energy. When energy flows, water will be through all systems and go to the plant. Function block. The functions of our system is to contribute water from one place to the plant by using solar electrical power. The function block represents the importance of each function we use. Context diagram. The arrowheads represent the direction of flow of the interaction between the external entities like user and the system, smart irrigation system. The system boundaries define what is inside and what is outside of our smart irrigation system. Morphological chart. Our functions are listed on the left side, while our different solutions and options are listed on the right side. Thus, this chart uses a matrix of functions as a mechanism that we use. Physics of design ideas. We use these four equations, where R is radius of tank, H is height of tank, L is length of tank, and W is width of tank. Concept design consists of three concepts. Concept 1 implements Arduino as the main controller of the system that controls sensor, valve, and pump. Water from water source to tank is done by electrical pump that will on and off depends on the level of water in the tank. The water level in the tank is monitored by a water level sensor. Capacitive soil moisture sensor is installed at the soil of the crops to detect the water requirements of crops. Design 2 was implemented by a PIC controller. The ram pump transports water from the water source to the storage water tank through the pipe. The float valve water level sensor will detect the water level of the water tank. The moisture of the soil is measured by a resistive moisture sensor. Solenoid valve is used for watering the crops when soil moisture is low. Concept 3 uses Raspberry Pi as the main controller. Water from water source to tank is done by electrical pump. Level of the water in the tank that is monitored by a float valve. Weather sensor is being used to detect weather and temperature at the soil of the crops to detect water requirements of crops. These three concepts will be generated based on methodological charts and the best concept will be chosen for our project. Last but not least, design parameter and constraint. In a project report, we need to identify which parameters need to be considered and additional parameters that need to be added to the list. Design constraints help to narrow down the choices when creating a project. Design constraints such as economical constraint, environment constraint, and sustainable constraint. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Husni bin Muhammad Rais, 1811 0857. I will tell about chapter 5, conceptual design. So first we start with pub chart. So pub chart is useful method that can identify the most promising design concept among the alternative generated. So in table 5.1, we choose kerana micro drip integration system as the dentung for the pub chart. So each criteria in the table we put plus or plus, minus or same for the three concept. After we fill all the criteria, we calculate how many times that plus and minus for each concept. And lastly, we obtain that concept 1 is got highest total written score, which is uh, 2, where the concept 2 obtain 1 and concept 3 obtain negative 1. So we see that concept 1 get total magnitude score is 2. Then next, in table 5.2, concept 1 is set for the rental scene has the highest number of plus and the highest total weight score compared to other concept. The total weight score of concept 2 and concept 3 obtain negative value. So we conclude all of that based on this table. We take concept 1 to we is the concept where it is best among the others concept generated. So next, within decision matrix. A within decision matrix is to use to compare alternative with respect to multiple criteria of different level of importance. There are list of value or row, column, and allow to analyze systematically, educate, and analysis and rate the performance of relationship between set of three value. So these two table is related which other. So smart irrigation is value 1.0, cost 0.3, and maintenance cost, for example, the value is 0.3. So next is rating factor. We multiply 3 rating before to get the value of each criteria. For example, maintenance cost, we get 1.0, multiply 0.3, multiply 0.3, so we get 0.09, and do same with other criteria. Then we get the rating for each concept of each design criteria is obtained by multiplying score and weight factor. So when we get the weight factor, for example, maintenance cost 0.09, so the score that we put is 9. So we multiply and we get 0.81. So the overall rating for each concept is sum of this rating. So the rating for each concept have been obtained. So if we see the table, concept 1 obtained 7.82, concept 2 9.95, and concept 3 6.79. So we take concept 1 as our design for use this method. Then analytical hierarchy process AHP. Analytical hierarchy process AHP is problem solving methodology for making choice for among of set alternative. The selection criteria will present multiple choice, have a natural hierarchy structure, or consist of qualitative and quantitative measurement. So if we think is equal, so we put rating factor 1. So if it's more important, so we put 3. And if is much more, we put 9 rating factor for between the the criteria. So the function of AFP rating is to create initial comparison matrix as shown in 5.7. So in this table, 5.7 cost compare with methodology. So cost is more important. So we put 3. Then after that, in table in 5.8, we calculate the criteria weight. So we get 0.182. Then lastly, in table 5.10 describe the consistency check W for smart irrigation system. Each criteria for A and B compared to assigned value for metric. Then we get the average value for consistency is 8.963 and consistency index 0.138. Consistency ratio is 0.098, lower than 0.10, and the level of consistency, we accept the level of consistency. Then we used to design alternative. So we compare three concepts. We compare about cost. So the concept one is the most suitable because concept one compared to concept three, concept one three more important, and concept three and concept one is 5 times more important. So we get design alternative P 0.634 for cost. And then after that, we get the average value for consistency is 3.038, and consistency index is 0.017. Consistency ratio is 0.29, lower than 0.10, and the level consistency is accepted. Then we do the same thing, repeating thing to the volume of tank and durability. So lastly, the selected design. In this project, the constituent one is selected as the final design project. It is selected due to making complex decisions using HP, WDM, and part chart that consider important criteria. These criteria were obtained from the result of HQ based on engineering judgment. The design consists of components which are electrical pump, capacity, moisture sensor, and polyethylene tank, lithium, battery, and HP. That's all for me. Thank you.